Hello guys, good evening. Welcome back. Okay, today we will talk about few features of Snowflake along with hands-on. Okay, we all know that Snowflake is a cloud native data platform. It is a data warehouse that allows organizations to store data, manage data, process data at very large scale. And the USP of Snowflake is it separates its compute layer, that is compute resources, from storage, so that you can get infinite amount of storage. You can bring your terabytes and petabytes of data into the storage, and it maintains compute layer separately, unlike traditional databases. If you take databases like SQL, like MySQL databases, PostgreSQL databases, in short, structured databases, we know that they are hosted on the servers. They use server storage, server compute capacity together. And when you want to extend the capabilities, you want to add more servers, you can create slave missions, whereas master will be that whole database. For read request, you have to clone the entire database in a slave server. So that is how we form clusters in structured databases, in traditional databases. But the Snowflake, it's coming with this USP. It is separating compute with storage. You are not using them from the same machine. They are completely different resources. And under the hood, the infrastructure is used is also completely different. And because of this feature of Snowflake, you can bring in cloud storages. Because storage is separate, compute will be managed by the Snowflake. You can create virtual data warehouses here, and you can process, sorry, and you can process that data and manage that data. And coming to this cloud storage, it could be internal storage of Snowflake, internally managed storage, which Snowflake refers as stage. It could be internal stage or external stage. You can add storages like AWS, S3, Azure Blob, or ADLS, they call it as Azure Data Lake Storage, or Google's GCS, Google Cloud Storage. You can bring these storages as a storage layer and you build a warehouse, and you can process and manage your data using SQL, Python, PySpark languages. So that is Snowflake environment. And in today's class, we will see how Snowflake works initially, and we will talk about some features of the Snowflake, which makes it different from traditional databases, furthermore different. And I already have an example notebook here to make our hands-on more interactive. I would like to create a notebook. This is worksheet. You'll have all the code together, and notebook, you can separate the code. You can run cell by cell, create a new notebook. And while creating the notebook itself, it's asking me to choose the database, and it will run on this warehouse, compute warehouse. So I'll choose one database for now. Let us say this database, choose Whatever database is available, choose it. You have a default database, choose it, and create the notebook. Okay, there is an example notebook. You can run Python code, SQL code, and Python code again. Right here, it is using some pandas library to transform data. Here it is a SQL code. You can query the data from the database and work with it. And here again, it is using pandas data frame. And you have these options. Click on it, a new cell will come up. You can run SQL because you clicked on SQL icon. Python and Markdown also available. Now let me delete these three. Okay, we will use some data set, a CSV file. I'll bring in that CSV file into the stage of our Snowflake internal stage. And from there, we will see how to set up the environment, that is data warehouse, database, schema, and the stage. And we will load the CSV file into the stage and then into the table. We will see how we can query, update, delete data. We will see some features about Snowflake like time travel and zero copy cloning. These are, I would say, key differentiator uh, that makes Snowflake special from traditional SQL databases. Now, the same thing, time travel or cloning, if you want to do in traditional databases, you need backups, you need to restore jobs. Here, cloning is instant, and also we have a feature called time travel. Okay, first let us set up the environment. And I'll also duplicate this tab. Yes, in this tab, I'll go to Snowflake homepage. And also open this demo one notebook worksheet. This is worksheet, this is notebook. And from here, I'll copy the code. First, I'll set up the environment. And all of this comes under setting up the environment of Snowflake. Before you start, of course, you can also use default databases, schemas and all. Here we are also seeing how to set up the environment. Okay, first we are creating a warehouse. We are separating from the storage. It's a virtual kind of a warehouse. We are calling it as demo warehouse. And we are selecting size as small and auto suspend. If you keep this data warehouse idle for 1 minute, it will be automatically suspended. And again, when you try to run it, when you call it, it will invoke, it will become active. That will save upon the costs. Auto resume true. When you run the code, it will automatically resumed. And initially suspended, yes, true. Let us run this. And if this data warehouse is already there, we will use it. Create a compute warehouse. And then we are saying create or replace warehouse demo warehouse. Actually, I should not be having this. Okay, delete this. This is the statement. Okay, that's why the exception. Yeah, demo warehouse successfully created. And then in the warehouse, I should create database schema. And within the schema, I can create tables or stage. Okay, we will create database and schema. Creating database schema. Database name is wholesale DB because I'm using wholesale customers data set. I'm calling this database as wholesale DB and create or replace schema, raw data. Right, the schema is like a folder where we can segregate different tables in these schemas. We can create multiple schemas under the database. Let us run this. Yes, schema successfully created. And here when you run these code in the notebooks, it will always display the last output, which is this one. And obviously database is also created. Without database, you cannot create a schema. Within this database, schema is also created. And then we will create a stage and the file format. Some error which we can ignore. If it really causes, I'll check it later. Okay, we are creating a stage. Stage is the storage which we are connecting with this data warehouse, or we are creating it and Snowflake manages it. We are using internal stage, not external stage. You can also bring in other cloud storages here. Stage is the place where you can save your data in raw format. If it is a CSV file, you can save it as it is. If it is a log file, you can save it as it is. It will not try to organize your data into table. But when you want to work with that file within the stage, you have to define what type of file it is. You have to define the file format. I am creating the stage in which I am going to upload the data. And also I am creating a file format because I know that the data which I am going to upload is a CSV. So I am creating a file format too here. Run this cell. Okay. Now I will upload the CSV file into this stage. And you can do that from the console. Right? You can just go click on this create button and you can go to stage, select the stage, Snowflake managed. And here you can create the stage. Sorry, not this one. SQL work, add data. Here it is. For this, it's asking me to end the session. Keep session running. Another tab. Okay, in the same tab it opened. Load data into a table. It came. Or if you load files into a table. Both the options are available. If you load file into the stage, it will be in its raw format only. That means in its original format. If you load file into the table, it will be loaded into the table into rows and columns. Accordingly, we can load. That is one option. And I'll go back to home and notebook demo 1. Time travel and cloning. Where is this notebook? Go back again. Okay, the worksheet it is showing. Go to all projects, notebooks. I didn't save the notebook. That's fine. We will create one more notebook. Choose the database. Later, if you want, you can change the database, create. Delete these cells and create a new SQL cell. And from here, I'll copy all of this, which we are using to set up the environment, and run this cell. Now in the wholesale stage, okay, I need to delete this again. Okay, now in this wholesale stage, which is internal storage, I'll upload my file, duplicate this tab, and you can use this add data option, and you can load files into a stage. Select the stage. Please select the database first. The database which we created, wholesale DB. And the schema, it is saying public wholesale DB raw data. That is the schema. And see, that is the schema we created. Wholesale DB schema is raw data. And there, select the stage, wholesale stage. And also select the path to an existing folder to create it. This is optional. Now I can browse and go to, yeah, this one, wholesale customer data. We are using that. Open and upload. I'm not doing this because I already have it. It might throw an error that this file is already there in the same storage, wholesale stage. So I'm closing it. I have created the database, schema, and the stage with the same name. And when I say here create or replace, if those schema, database, and stage, if they doesn't exist, it will create. If they are already there, it will use it, create or replace. So we are replacing, actually, not reusing. It's better to add the data only. Okay, upload. And wholesale DB, raw data, wholesale stage, all we selected, upload. Yeah, one file uploaded. Now coming back, I'll open another cell. And this time I'll create table. See, these an unexpected error occurred. Try refreshing the page or contact support if error persists. Let us see if it is keep on showing this. I'll try refreshing the page. Okay, I'm creating a table because Snowflake is a structured data warehouse. You have to define the schema. If you want to write data into the tables, you have to define the table first. Of course, these data warehouses, they are not very rigid on schema like databases, but you have to provide initial schema. And if upcoming data is, there are any data type mismatches, etc., Snowflake on its own can modify. And also it gives unstructured data or semi-structured data, not unstructured data. Semi-structured data like JSON and Parquet support is also available. But first you need to define a table. And these are the attributes in my data set: channel, region, fresh, milk, grocery, frozen. Let us have a look into our data set. So this is the data set. Now let us go and run this cell. Yeah, we created this table also. Next, we will load data from stage into the table. First, I want to list out the files in the wholesale stage. I have uploaded a file. I want to verify whether the file is there or a couple of files are there, or with what name it has been stored. The same name, wholesale customer data.csv. You can see the size and MD5 and the last modified date also available here. In the same way, yeah, there is nothing to check as of now. We have empty database and empty table. We are copying from wholesale stage into customers table, which we have created earlier. And we already know that wholesale stage is having the CSV file. From here, we are uploading data into the customers. And also we have given the file format. It's a CSV file. If it is a JSON file or a Parquet file, accordingly, you will create a file format. And when you copy it, you have to also mention the file format. And with these details, we are copying into the table. Let us run. Okay. Now let us verify. We are counting from the customers table, which gives you number of rows. Why this error is coming again and again? But I was able to execute all the cells. So let us ignore that error. And you can see the number of the number of rows in the data set from the customer table is 440. And also we will have a look at the first 10 rows. And you can see the first 10 rows, 0 to 9, and all the column names which you have defined while creating table, and data has loaded properly. Okay, now we understood what a stage is. Stage is the place where you can bring your raw data. And you have to set up data warehouse, database, schema, and then stage. If you want to bring in data in file format, not only manually, programmatically, or through any applications, if you want to automatically load data, and if you don't know the schema of that data, it is always better to bring in data to stage first. So we brought data to stage first and then copied it into the table. If you already know that data is structured, then you can directly load data into the tables. No need of loading data into the stage. Now we will talk about very interesting feature of Snowflake, that is zero cloning and time travel. We will discuss about these two features. I'll go here. First, we are deleting a few rows. And this is the SQL statement for that. And you can see the attributes are like this: channel, region. And we are selecting all the rows which are having channel is equal to 1. And we are deleting those rows. After making this delete operation, we are counting number of rows from the customer table. And you can see the drop in the count. Earlier it is 440. Now we have 140 rows. In Snowflake, okay, we have a feature called time travel. Suppose if that is an accidental delete, or you realize that there are some rows which are important, you should not delete them. Now you wanted to restore them back. See, now you can query the table. You first don't want to restore, just you want to access the deleted data also. Then you can query using the time travel. This is a query which is using time travel. This particular function at, and you're saying offset is equal to greater than or greater than equal to minus 60. So what it says is, about 1 minute ago, right? We have done something, some operation. So 1 minute ago, it was just done now, right? Obviously, even 1 minute has not been passed away. 1 minute ago, table has certain number of rows. And this table gets those rows before delete operation. We will quickly run this because we have given it's only as minus 60 window. 1 minute is done. Let us say 120. You see, 440. Like this, you can give some time, time limit here, and accordingly you can travel back and query. Here I am counting. If you want to filter, if you want to average, if you want to find minimum, maximum from the deleted data, all you can do. Now, not only querying, you can also restore it. To restore, yes, update, count, select. Okay, we drop and undrop. So this is how you query the table. Just give me a minute. Okay, now I want to restore the tables. So I'm creating a new table, customer restored, and I'm cloning the customer table at offset greater than minus 60. Now I'll say some minus 300 seconds. Some 300 seconds ago, we used to have some table status. Now after deleting, we have only 142 rows. Now we want to restore that old version table. And Snowflake stores all these versions up to 90 days in the licensed version of Snowflake. And how long you can go back? Up to 90 days. Suppose 80 days back deleted rows, 80 days back deleted table also you can restore. After 90 days, it's not possible. But for standard Snowflake, it is only 1 day. Within a day, you can restore your tables or rows, right? Here we are saying about 300 seconds ago, I want the table in that version. And we are counting the number of rows from that restored table. We are cloning and counting. Let us run this. Okay, now let us increase some 400 seconds back. We will restore. Yeah, you can see the time travel, how it is working. The old table has been restored. Now it is available with the name customers restored, and your current table is available as customers. Both the versions are available. This is your current version. This is the old version that is got restored. Suppose the entire table has been dropped. Then you can use drop and undrop. Drop the table customers. Drop it. And we are selecting the same. I mean, we are verifying the same. It is empty because we deleted that table. Now you drop the table, you just say undrop the table. And also we are counting the number of rows. See, customers. Customers is the table where we have deleted the data. And the restored table is with a different name, customers restored. And it has only 142 rows after the delete operation. Now let us do some update. Okay. And this is the update operation we are doing to the table. What we are doing, we are setting the entire fresh column. We are reducing it to half. Something like we want to provide a discount. We have given 50% discount on the fresh groceries. And it has been set to half of the prices. And we are calculating the average price of the fresh column, fresh groceries column. See, the table has been updated, but I want to know what are the average price of the fresh groceries before the discount, before the update. See, just 60 seconds ago, you can check it out and run it. See, before update, after update. And this is the old version table. This is current table. And then you can clone, right? We have already used this. You can clone the old version table. I'm not running it again. Okay, query the history and find out. If you are the one who are doing all these operations, you know. Even if you are the one, you have updated the table or deleted the table, a few rows in the table. You don't know like the exact time. You have to roughly estimate, but it will be good if you know the exact time. You can mention that time and restore the tables, or you can query back at that time. And this particular information schema will be available. If you go and check for when you create a data warehouse or a database, along with the schema you have created, there will be another schema called information schema. And this schema carries all the history, what you have done to that table. And you can also query that table query history, which is saved in information schema. It is the table, the schema managed by your Snowflake. And we are selecting query ID, query text, start time. And from query text, we are checking delete, update, drop when they are happened. And we are ordering the start time by descending so that you will come to know what are the top manipulations that has been done to that table. Run this. See, a couple of people or a team of people are managing. You have newly came and you don't know what happened earlier. Now you have been asked to restore or query the old version tables. This will be helpful. Now you know that information schema has a query history table. You can go there and understand the history of operations that performed on that table. You can see start time, right? Query text, what happened, everything you can understand, and accordingly you can plan your query or cloning. Or you can also say this one. So this in particular, we are requesting query text like delete, update, drop. Just you want to know what is the last alteration that has been done to your table. Just select everything from information schema.tables and table name customers. This time we are not querying query history table. Just for the table customers, what is the last alteration that has been happened? Just run it. You will get a detail. If you go and check there, you will come to know when the time it has been last altered and what last DDL time and who done it. You can give access to the multiple users, and it will also show you who has done the alteration to your table and what type of alter and when it has been done. So all these things you'll get to know. Accordingly, you can restore or go back, time travel, and query the old version tables. Okay. Now cloning. See, we are saying a count from the customer's clone. First, I should clone it, right? Create or replace. Clone. Run this. Yeah, table customers clone has been successfully created. And this cloning is not it's not you are creating another physical table. With this command, you are creating some kind of duplication for your dev and testing. You already have the physical table. You are cloning it because a data analyst or a business user or a regional manager of that grocery store, they want to know how the sales are happening. They asked you to grant access to the table, but we are not sure to grant the access to actual physical table. So we are cloning and giving that access to the clone table for development purpose, for testing purpose, right? And here the advantage in Snowflake is this is called as zero copy cloning. That means the table is not copied at all into a physical table. It is just a duplication done virtually. Just it will set a pointer towards the physical table and it will create some virtual table. So you don't pay for the actual storage. That is zero copy cloning, which is very useful for development and testing, right? And you can do all the SQL like how you do on physical tables. You can also perform them on the clone tables. You will be only charged or billing will be for this compute environment, the compute which you have used, but not the storage, because it is not cloned into a physical table at all. And you can see 142 rows are there in the clone also. We cloned it from the customers table. Right, those are some features which make Snowflake very different from traditional SQL databases. Right? Let us summarize. Right, Snowflake manages storage separately, compute separately. And before you use storage, first you have to set up the environment. First you have to create data warehouse, and within the data warehouse you have to create database and then schema. And in the schema you can create stage or table. Even though stage has nothing to do with data warehousing, because it saves data in file format like .csv, .json, .parquet, but Snowflake made it mandatory. You have to connect stage with the data warehouse so that you can seamlessly load these data into table of the same database and in the same schema, because you have attached stage to the same database and schema. And here you can create a table and copy the files into the table. And already the structure itself is very different from traditional SQL. Compute is a different one, storage is a different one. The computers underneath of compute are different one. The servers underneath the storage is different. That's how Snowflake already different from traditional SQL. And further, there are some features like time travel. Snowflake maintains all the old versions tables also. You can go back and query them. If you want, you can restore them. And also you can clone the tables, create a copy, something like view. In traditional SQL databases, you can create views, but here cloning is a lot more simpler. You can create clones. It's called as zero copy cloning. And you can interact with these clones, which are similar to views in traditional SQL databases. So that is about Snowflake and a few of its features. Yeah. Thank you.